Okay, good morning, everyone. I am going to cover page 380, numbers 21 through 32 in this video. These are the problems that I had posted along with lecture on April 1st. So on page 380, for number 21 through 24, these four problems simply involve you typing into your calculator, into your graphing calculator, what they gave you. The directions are for you to use a calculator to evaluate f of x equals log of x. Notice there is no base on this log listed, therefore it's base 10, so we can simply use our log key. So the first one, you're going to press the log key followed by 7/8, and then your enter key, and you get negative 0.05799. The next problem is log of 1/500th. That gives us an answer of negative 2.6989. Then we have log of 12.5. Make sure you're closing out the parentheses. It probably won't matter either way, but it's a good habit to get into because later on we're going to have problems where there's more than just one number involved in the log equation. That gives us 1.0969. And our last one that we were asked to do for that set was log of 96.75, which gives us 1.98565. Okay, so you shouldn't have had too much trouble with those, maybe locating the log key on your calculator. As a side note, if you are trying to use a scientific calculator, for instance, on your phone, if you have the scientific calculator pulled up on your phone and you actually turn your phone sideways, so it's long sideways, there should be a log key that appears in a regular scientific calculator. You don't have to have a graphing calculator to do that particular part. Now, 25 through 28 asks you to simplify using properties of logarithms. Now, these are a little bit trickier just because this is going to rely on you knowing what property to use in order to do that. So I'm going to flip back to the properties of logs in this second section that I gave you, which are right here, and we're going to key in on these. So if you look at the first one, this problem here we're looking at, this is log base 11 of 11 to the 7th power. And the thing that I want you to key in on is the 11s match. The base of the log matches the base of the exponent. So when we flip back to these rules and we look at rule number 3, you can see that this is log base a of a to the x. So notice that the base of the log matches the base of the exponent. And when that happens, the log and the base, both bases cancel, and you're just left with the exponent x. So going back to our homework here, you can see then that this particular problem just turns into, and you'll have to bear with me, 7. Because the 11s cancel like that. Okay, number 26, you can see it's log base 3.2 of 1. Flipping back to our rules again. Anytime you have log of 1, no matter what the base is, you can see it's base a there, but anytime you're logging 1, no matter what the base is, the answer is 0. Therefore, looking at number 26, this entire problem turns into 0. All right, moving on to number 27. We have log base pi of pi. Now this one is very similar to the one right above it where we had log base 11 of 11. In this case, the log base 11 of 11s, the 11s all canceled out and we're left with just the 7. This one's even simpler. If you have the base and the number that is being logged, if they match, referring back to these rules, when you have log base a of a, it turns into 1. So this, number 27, equals 1. Okay, now the last one is, I would say, the trickiest one out of them all, but it's 9 to the log base 9 of 15. The key thing about this is to look at the base of the exponent, which is 9, and the base of the log, which is also 9. Anytime the base of the exponent and the base of the log match, they will cancel each other out, and you'll simply be left with whatever number is left. So in this case, the 9s go away, and this just equals 15. This particular problem utilizes this rule right here where you have a to the power of log base a of x. The a's cancel as does the log, and you're just left with x. Okay, so that finishes up the homework problems from the second part. Now we need to look at 29 to 32. For this, I'm going to switch over to a whiteboard because I want to be able to write on here and solve these. So number 29 gives us log base 5 of x plus 1 equals log base 5 of 6. Now you can notice that the logs are the same, bases are the same. It's saying to use the one-to-one property. Therefore, all we have to do is write x plus 1 equals 6. We can subtract 1 from both sides, and we get x equals 5. So that one was pretty easy. Here's number 30. Number 30 is log base 2 of x minus 3 equals log base 2 of 9. As you can see again, the logs and the bases both match. Therefore, you're going to set x minus 3 equal to 9. You're going to add 3 to both sides, and you're going to get x equals 12. So that one was pretty easy as well. Now the next two are pretty much equally as easy. The next one is log of 2x plus 1 equals log of 15. And as you can see, there is no base listed, therefore it's base 10. And since both the bases match, you're going to set 2x plus 1 equal to 15. And that one's going to involve 2 steps. You're going to subtract 1 from both sides first, and then you're going to divide by 2. And you get x equals 7. I'll move that up so you can see it. The last problem here, number 32, is log of 5x plus 3 equals log of 12. Once again, there's no base listed, so it's base 10. And both the bases match, therefore we're just going to write 5x plus 3 equals 12. From there, we're going to subtract 3 from both sides. And then we're going to divide by 5, and we're going to get x equals 9/5. And I'm perfectly okay with you leaving that as an improper fraction. All right, there you go. Those were the practice problems from the lecture notes on 4.1. Hope you have a good day.